So I guess this is the perfect time to start this inauguration ceremony. The afternoon is pleasant and it's an honor in itself for me to host this talented and hardworking audience who has gathered here to attend this national conference on advancements in interdisciplinary research 2021. I, Dr. Shiba Sethi, Joint Organizing Secretary of this conference, welcome you all on behalf of the whole organizing team of NCAIR 2021. First of all, before we could begin with the sessions of the conference, it would be incomplete if I had not named the organizing persons who have been involved in this conference. So I would like to call upon various people like Dr. Zafriab Jilani ji, who is Senior Advocate and Manager of AIDCL Amiruddala Degree Medical College, Lucknow, who is the Chief Patron of the college, who is the Chief Patron of the conference. I would also like to name Mrs. Shweta Singh, who is Chairman, Governing Body of MKSE's Education Society, Lucknow. She is also the Chairperson of the conference. I would like to mention the name of Professor R.K. Shukla ji, who is Professor, Department of Physics, University of Lucknow. He is the Program Chair of the conference. I would like to invite him first, Professor R.K. Shukla ji, to speak few words on the conference.
Okay, thank you, Dr. Shiba. Good morning to all of you. I welcome all the participants and all the invited speakers. First, I would like to thank Mr. Zafriab Jilani ji, Manager Islamia Degree College, Dr. Abdul Qayyum, Principal Islamia Degree College, Dr. Dilshat Ahmed Ansari, Convener of this conference, Dr. Shiba Sethi, Secretary of this conference, Dr. D.K. Yadav, Organizing Secretary, and Nishant Kumar is also Organizing Secretary. I also thank Mrs. Shweta Singh, Chairman, MKES Educational Society, and Dr. Sushil Singh, Director, Science Tech Institute. I would like to welcome Professor N.B. Singh sir, Professor Purushottam Chakravarti, and Professor D.S. Huda. They are involved as senior advisor in this conference. This conference includes the various topics pertaining to interdisciplinary research in science and technology will be discussed in this technical session. These topics are related in material science, nanotechnology, medical science, computer science, and humanities. I and our team is extremely overwhelmed with the response of this National Conference on Advancement in Interdisciplinary Research. This would not be possible without your contribution. So a heartfelt thankful to all the participants and invited speakers. In this conference, there are 20 invited talks and 88 oral presentation and 14 poster presentation. The invited speakers are Professor N.B. Singh sir, Dr. K.P. Mishra, Professor Ranjana Jha, Professor A.K. Mishra, Dr. S.K. Yadav, Dr. S.K. Mishra, Dr. Mohammad Mia, Professor Anil Mishra, Dr. Sasikant Sharma, Dr. Nisha Mani Pandey, Dr. Man Ghoshal, Dr. Shiba Sethi, Dr. Poonam Jain, Dr. Yogesh Kumar, Dr. Nishant Kumar, Dr. Dharmen Kumar Yadav, Dr. Jeenat Kashmiri, Dr. Priyanka Singh, and Dr. Anjan Akhtar. In this conference, there are more than 150 participants are registered in this conference. We are published a book chapters with ISBN for contributory paper presented in this conference. Once again, I welcome everyone. Jai Hind, Jai Bharat.
Thank you, Professor R.K. Shukla ji, for giving a beautiful introduction to the conference. I would also like to welcome Dr. Abdul Qayyum on behalf of other organizing people of the conference. He is Principal of Amiruddala Islamia Degree College, Lucknow. We welcome you, sir. I would also like to call upon Dr. Dilshat Ahmed Ansari, Associate Professor, Department of Commerce, AIDC Lucknow, to share his views about the conference.
Good morning, everyone. National Conference Advancement in Interdisciplinary Research NCAIR 2021 में हम सभी का स्वागत करते हैं। हमारे प्रिंसिपल साहब जो कि आज एक बैठक में बिजी हैं, इसकी वजह से वो शामिल नहीं हो पा रहे हैं। और इस कॉन्फ्रेंस में जैसा कि हम लोग सब जानते हैं कि जो है दुनिया जो है कोविड-19 से जो है पीड़ित है और एक नए मोड़ पर लाके खड़ा कर दिया गया है। और इस समय जहां तक मानवता के अस्तित्व की बात है, वो उसके लिए नए नए इनोवेशन और इंटरडिसिप्लिनरी अनुसंधान एक महत्वपूर्ण है। और नई शिक्षा नीति में इंटरडिसिप्लिनरी जो की ही जरूरत है कि कोई भी लड़का जो चाहे स्विच ओवर भी कर सकता है, तो उसको भी ध्यान में रखते हुए ये आज की कॉन्फ्रेंस महत्वपूर्ण होगी, जो कि आजकल की जो हमारी जो टेक्नोलॉजी है उसके आदान प्रदान के लिए इन दोनों जो है नैतिक अनिवार्यता बन गई है। इसके लिए हमारे जो शिक्षक समुदाय हैं और जो पढ़ने लिखने वाले लोग हैं, इनको साइंटिफिक तरीके से टेक्निकल जो है चीज़ों के बारे में, नई नई चीज़ों के खोजों के बारे में एक बेहतरीन खिलाड़ी बनने की ज़रूरत है। और जब तक हम नहीं बनेंगे तब तक हम इसमें कुछ नहीं कर सकते जो इतना बड़ा बदलाव आया है। और कोविड-19 एक आपातकाल मुकाबला है और इसके मुकाबले के लिए सभी तैयार हैं, लेकिन इसके साथ साथ हमारी शिक्षा और जो है आपकी जो है इंडस्ट्री है, ये दोनों पूरी तरीके से ध्वस्त हो गई है। इसको भी आगे बढ़ाने के लिए ज़रूरत है। एक सच्चे जो उद्योग लोग जो चला रहे हैं, उनकी आगे बढ़ाने के लिए, उनको मोटिवेट करने के लिए इस टेक्नोलॉजी का इस्तेमाल किस तरीके से किया जाए, उसकी एक ज़रूरत है। तो शिक्षा को प्रदान करने के लिए सोशल डिस्टेंसिंग के युग में हमारा मीरुद्दौला इस्लामिया डिग्री कॉलेज और साइंस टेक इंस्टीट्यूट जो है 3 दिवसीय कार्यक्रम का एक सम्मेलन का जो आयोजन किया गया है, इस प्लेटफॉर्म पे तमाम लोग इसमें शामिल होंगे, जिसके हमारे चीफ पैटर्न जो है मिस्टर जफर याद दिलानी जो एडवोकेट हैं, अंतर्राष्ट्रीय ख्याति प्राप्त हैं, इस वक्त वो अस्वस्थ हैं, हम कामना करते हैं जल्दी स्वस्थ होंगे। और सुशील जी अगली जो वेबिनार या सेमिनार कराएंगे उसमें इनके बहुमूल्य विचारों से हम लोग लाभान्वित होंगे। इसके अलावा इसमें हमारे एडवाइजर प्रोफेसर पुरुषोत्तम चक्रवर्ती जी है न्यू जर्सी से यूएसए से, प्रोफेसर एन.बी. सिंह है शारदा यूनिवर्सिटी ग्रेटर नोएडा से, प्रोफेसर डी.एस. हुड्डा जी हैं हिसार हरियाणा से, और जो प्रोग्राम को जो चेयर कर रहे हैं, बहुत मेहनत उन्होंने की है, प्रोफेसर आर.के. शुक्ला जी, इनको परिचय की ज़रूरत नहीं है, इनके तमामों किताबें हैं, तमामों इनके रिसर्च पेपर हैं, और 24 घंटे ये अपने जितने भी स्टूडेंट्स हैं तैयार रहते हैं, ये समय नहीं देखते हैं, बस अगर आप कोई पढ़ने वाला लिखने वाला है उसका साथ हमेशा देते हैं। डॉक्टर कयूम जी हमारे प्राचार्य जी हैं, आज हमारे उसमें प्रोग्राम इस वक्त नहीं शामिल है क्योंकि 12:30 बजे उनकी एक आपातकालीन बैठक बुलाई गई है कॉलेज के अंदर, इसलिए वो नहीं आए, तो उनकी तरफ से भी हम आपका धन्यवाद करते हैं। चेयरपर्सन में हमारी जो है श्वेता सिंह जी हैं, जो गवर्निंग बॉडी की चेयरमैन हैं, एनर्जेटिक हैं। इसके बाद हमारे जो 3 प्लेयर हैं इस कॉन्फ्रेंस में, सुशील सिंह जी हैं, निशान जी हैं, डॉक्टर यादव जी हैं, डॉक्टर डी.के. यादव जी जो स्टैटिस्टिक्स डिपार्टमेंट से शायद नई दिल्ली से हैं, बहुत ही डायनेमिक पर्सनालिटी है। और हमारे जॉइंट ऑर्गेनाइजिंग सेक्टर के शिवा सेठी जी हैं, PGIMS, ये डॉक्टर भी हैं, और इस वर्चुअल जो समय में वर्चुअल भी इलाज शुरू हो गया है। गवर्नमेंट ने तमाम जो है लैंडलाइन नंबर और अपने मोबाइल नंबर दिए थे, किस तरीके से ये इलाज हो सकता है, क्या ये संभव है, ये चीज़ें भी इनको बताएंगे आपको अभी 3 दिन में किसी ना किसी दिन। इसके अलावा हमारी जो टीम के अंदर जो उन्होंने महत्वपूर्ण अपने योगदान दिए हैं, डॉक्टर D.K. शर्मा जी ये USA से हैं, O.P. यादव जी हैं नॉर्थ डकोटा स्टेट यूनिवर्सिटी USA से हैं, डॉक्टर आकांक्षा सिंह है दुर्गाम यूनिवर्सिटी यूके से हैं, और श्रवण शारवरी शुक्ला जो जी हैं ये हमारे कल पुणे से हैं, प्रोफेसर मुन्ना सिंह है लखनऊ यूनिवर्सिटी के हमारे, प्रोफेसर रंजीता पांडे हैं DU से दिल्ली यूनिवर्सिटी से, डॉक्टर आकाश अस्थाना है लखनऊ विश्वविद्यालय से, डॉक्टर प्रतीक्षित सिंह है जो हमारे मुख्यमंत्री जी का शहर है दिग्विजयनाथ डिग्री कॉलेज है वहाँ से हैं, रंजीत राजीव रतन सिंह है राम मनोहर लोहिया इंस्टीट्यूट लखनऊ से हैं, डॉक्टर सुशीला के जी हैं वो KM गवर्नमेंट कॉलेज नोएडा से हैं, प्रिया सिंह है KGMU लखनऊ जो KG मेडिकल कॉलेज है वहाँ से हैं, शैलेंद्र कुमार बुंदेलखंड यूनिवर्सिटी झांसी से हैं, मीनाक्षी यादव जो है CCS चौधरी चरण सिंह यूनिवर्सिटी मेरठ से हैं, विवेक अग्रहरी ISD-C PG कॉलेज प्रयागराज जो अब इसका नाम नया इलाहाबाद से प्रयागराज हो गया है, SN मिश्रा जी बलिया जी से हैं, और डॉक्टर साजिद हमारे हेड ऑफ द डिपार्टमेंट हैं कॉमर्स के, ये AMU से हैं और इन्होंने भी कई किताबें लिखी हैं। और आज की मिस्टर जफर याद जिलानी की जगह पर असिस्टेंट मैनेजर का जो चार्ज लिए हुए हैं मिस्टर अतहर नबी साहब हैं, और नौशाद संगीत केंद्र आपका नाम सुना होगा, नौशाद जी जो हमारी जानी मानी फिल्मी हस्ती रहे हैं, तो उसके ये अध्यक्ष भी हैं और हमारे कॉलेज के इस वक्त जो है असिस्टेंट मैनेजर के रूप में काम कर रहे हैं। तो हम सभी का स्वागत करें, जितने पार्टिसिपेंट हैं जिनका मैं नाम भूल गया हूँ तो उसके लिए मैं क्षमा चाहता हूँ अगर कोई रह गया हो। तो हमारी जो डायनेमिक पर्सनालिटी हमारे बीच में जो प्रोग्राम को होस्ट कर रही है डॉक्टर शिवा सेठी जी अब आप इसको आगे कंटिन्यू करें। थैंक यू।
थैंक यू सो मच डॉक्टर दिलशाद अहमद अंसारी जी। वैसे तो आपने बखूबी सभी ऑर्गेनाइजर्स को इंक्लूड कर लिया है अपनी इस लिस्ट में, बट मैं यहाँ पे ऐड ऑन करना चाहूंगी कि डॉक्टर दिलशाद अहमद अंसारी जी जो कि अमरुद्दाला इस्लामिया डिग्री कॉलेज से हैं, इस्लामिया डिग्री कॉलेज और साइंस टेक इंस्टीट्यूट इन दोनों ने मिलकर इस कॉन्फ्रेंस की ऑर्गेनाइजेशन में पूरा रोल निभाया है। तो कुछ चीजें मैं इन दोनों इंस्टीट्यूट्स के बारे में ऐड ऑन करना चाहूंगी फॉर द इंफॉर्मेशन ऑफ जनरल पब्लिक हु इज अटेंडिंग दिस कॉन्फ्रेंस. So, talking about Amiruddala Islamia Degree College, Lucknow, this college occupies a distinct place amongst chosen few educational institutes of Lucknow, the city of learning and cultures. This college is imparting education to the students of nursing till graduation. The course of arts, science, and commerce are available at all the levels. The special emphasis of institute faculty specifically on character building, teaching, and discipline. Faculty members of this college are highly devoted, have good academic credentials, and have extensive experience in their respective fields. And we have already seen one of the faculty members right in front of us, Dr. Ahmed Ansari ji. Now, moving towards the next institute, which has played an important role in organizing this conference, is the Science Tech Institute. Science Tech Institute is one of the premier institutes of Lucknow, who is dedicated to organize various academic activities like conferences, seminars, workshops, various other training programs in collaboration with national and international organizations. It has its own publication house wherein they publish the edited books, course books. Along with it, they have their own journal to publish research articles. This institute has been set up by Manraj Kubar Singh Education Society, Lucknow, which works basically to provide education to poor, low socioeconomic status children. So, with the brief introduction of the two organizations who are involved in basically carrying out this conference, I would like to invite upon Dr. S.K. Singh, who is the organizing secretary of Science Tech Institute, MKCS Education Society, Lucknow, is also the one of important organizers of this conference. So I would like to call upon S.K. Singh ji to share a few words about this conference.
Thank you, Dr. Siva Sethi. First of all, good morning to all of you, all the participants, all the organizer members. And I would like to great thank to Mr. Jafar Abjanali, Senior Advocate, High Court and Manager of Islamia Degree College. He allowed to conduct 3 days National Conference on Advancement Interdisciplinary Research. And I would like to thank Professor R.K. Sukla sir. Without his blessing, it was not possible to conduct this 3-day conference. So I would like to great thank to Professor R.K. Sukla sir. And I would like to also thanks to Mrs. Sweta Singh, Chairman Manraj Kumar Singh Educational Society. She allowed to jointly organize this conference with Islamia Degree College and this society. And I would like to thank Principal Dr. Abdul Qayyum, Islamia, he's a Principal Islamia Degree College. And I would like to thank to Convener Dr. Dilshad Ahmed Ansari. He's Associate Professor in Amruddala Degree College. And Dr. Nishan Pandey, he belongs from Department of Physics, MUIT, Lucknow, UP, India, and Dr. D.K. Yadav, Organizing Secretary, National Health Ministry and Women Welfare under the Ministry of Health, and Dr. Siva Sethi she is a Joint Secretary, belongs from PGIMS Rohtak. So I would like to also thank our senior advisor of this conference, Professor Purushottam Chakrabarti, Professor N.V. Singh sir, and Professor D.S. Hodda. He is Pro Vice Chancellor, GJ University of Science. And there are many more names. He already said that Dr. Dilshad Ahmed Ansari sir. And So without these teams, it was not possible to conduct this national conference, virtual national conference on interdisciplinary research. So everything said by the Dr. Dilshad Ahmed Ansari, so I cannot repeat to those words. So thanks to Dr. Dilshad Ansari for brief introduction about the person of this conference, about the conference. And I request to Dr. Siva Sethi invite to all organizing members to say few words about this conference. Thank you, Dr. Siva Sethi.
So I would like to call upon now Dr. D.K. Yadav ji from Department of Statistics and Demography, NIHFW Delhi, to say a few words about the conference. Dr. D.K. Yadav ji.
Yeah, thank you, Dr. Siva, for your invitation. And I'm really thankful to Science Tech Institute and Amiruddaula Islamia Degree College for this wonderful academic event, which is going to be very, beneficial for all students. Of that. And because many of our organizing members have told you about the whole program of this particular conference. So myself, Dr. Dharmendra Kumar Yadav, the organizing secretary of this conference. And presently I'm working in the Ministry of Health and Family Welfare, Government of India, New Delhi. So right now we are facing two problems. Okay, so the first one is COVID-19 situation. So from the last 1.5 year, we are facing this problem. And the second, it's not a problem, but it's a transition phase. That is new education policy 2020. So new education policy 2020, you can say that it is more emphasized on the interdisciplinary research and education. So we have already, the Science Tech Institute has already organized a FDP on this new education policy. And I am also associated with this Science Tech Institute and Amiruddaula Islamia Degree College from last 1.5 year. And I'm thankful to our guide and motivator, Professor R.K. Shukla sir, for giving this opportunity and always motivating us to organize such events. We are thankful to the senior advisor and professor, Professor N.B. Singh sir, who is emeritus professor at Sarda University, Noida. Our esteemed professor, Professor D.S. Hooda sir, he is a former pro vice chancellor at MD University, Rohtak. And our colleague and our fellow, and that is Dr. Dilshad Ahmed Ansari ji, Dr. Nishant Kumar Pandey ji, Dr. Shiva Shetty, and you can say that it is a very important and strong pillar of Science Tech Institute, that Dr. S.K. Singh ji, for involving me in and giving me the opportunity to interact with all academicians throughout India. And I also thankful to Mrs. Sweta Singh ji. She is a governing member of a governing person, chairperson of this governing body of this MKS society. So thanks to all of you, and most importantly, I would like to thanks to all the participants, because without your support and participation, this event was not possible. So as Dr. R.K. Shukla sir has already told you that we got more than 100 abstract in this conference. We have more than 20 invited talks from the eminent speakers all over India. We have some 14 poster presentations in this conference. So we are also planning to, since the Science Tech Institute has its own publication house, so we are also planning to, publish the proceeding of this national conference in the form of edited books. So we are really happy to get your, publications, your research papers in these edited books. So with this all, I'm thankful to each and everyone who is associated with us directly or indirectly. So thank you. Over to Dr. Siva.
Thank you, Dr. D.K. Yadavji. Now, I would like to call upon Dr.
No,
Nishant
Dr.
Kumar.
Siva Sethi, I'm interrupting to you. Kindly call to Principal Amritullah Islamic Degree College, Dr. Abdul Qayyum. He is present. So I request you please call to him.
Okay. So I would like to call upon Dr. Abdul Qayyum, the principal of Islamia Degree Medical College, to please share some few words.
आपका कैमरा ऑन, आप बोलिए क्या रहे हैं?
So please share your few wonderful words about the conference.
कॉन्फ्रेंस के लिए कुछ बोल दीजिए आप क्या रहे हैं? हेलो,
Welcome to all of you, and thanks to Dr. R.K. Shukla ji, Dr. Sushil Singh, Dr. Dilshad Sahab to organize this conference. I hope this conference is very fruitful for researchers and teachers. Thanks all of you. Okay.
Now, Dr. Siva Sethi, you proceed. Yeah.
Okay, thank you so much, sir. Now I'll like to call upon Dr. Nishant Kumar, who is Assistant Professor from Department of Physics, MUIT, Lucknow, to share a few words about the conference.
Thank you, Dr. Siva ma'am, for inviting me. I am audible to all of you. Hello.
Yes, you're audible.
Okay.
Yes, audible.
Good afternoon to all of you. I am welcome to Professor N.B. Singh sir and Professor R.K. Shukla sir and other participants who has participated and supported us in the conference in direct or indirect way. And this is the difficult time after the second wave of COVID pandemic, which has brought us all together on virtual platform to share our views on advancement in interdisciplinary research. Interdisciplinary research is the essential requirement of today's world. The knowledge origin are fast expanding, and at the same time, they are merging together, making almost all the domains are interdependent, be it science or technology or even commerce and management. On the behalf of the whole organizing team, I welcome to all of you. I wish you to all very fruitful session, which I am sure are going to be a great learning for all of us. And again, I welcome all of you again. Thank you.
So now I'll hand over the mic to Dr. D.K. Yadav to carry on this conference to further level.
So, Dr. Shiva,
Yes.
now I would like to invite our professor and senior advisor who is with us, Professor N.B. Singh sir. So kindly give your blessings for the success of this particular national conference. So, Professor N.B. Singh sir.
Am I supposed to give my talk or just few words?
Few words, sir.
Just few words, sir.
Few.
For your blessings.
Good afternoon to all of you. I congratulate the organizers, members of the organizing committee, and the whole this organizing group for organizing such a wonderful conference, which is very much timely. Now everything is changing with time, and that too with the COVID-19. Now, what we used to have in a physical mode, that has been changed to online mode. And apart from that, new education policy is emphasizing a lot of things for research-oriented teaching. And I hope that this conference will add or will support the National Education Policy 2020, one step ahead. And also today at 4:30 p.m., Honorable Prime Minister of India, Mr. Narendra Modi ji, will address the nation regarding this new education policy. So I request all of you to attend his deliberations and his speech so that we can strengthen ourselves towards the new coming education policy. Thank you very much.
So thank you so much, sir, for your wonderful words and blessings. And we are sure that we will get your blessings and guidance in the near future also. Yeah, so sir, can we start the next session or first invited session?
Yes.
Okay. So dear participants, now it's this our inauguration session has been over, and now we are going for the academic contribution or for this particular conference, which is the purpose of this conference. So we are moving towards the first this session, that is the invited session. So we have 4 invited speakers in this this particular session. So, and a very renowned and very good researcher, Professor R.K. Shukla sir will be the chair of this session. So before starting this session, I just want to say a few words or just an introduction about Professor R.K. Shukla sir. Although it's not possible to say very few words because he has a so supportive and a very good researcher and human being. So Dr. Shukla is a professor at Department of Physics, University of Lucknow. He has a wide teaching and research experience in the field of physical sciences. He has more than 100 research papers in the national, international journals. And he has the author of 10 books on the various areas of physics. He has 2 patents in his credit. He is the awardee of around 15 reputed academic awards for his wonderful contribution, academic contribution to the society. He has completed 5 research projects from the various national and international agencies and successfully guided 8 PhD students. So we are really thankful to you, sir, for being with us for all the time from the very beginning of any program and for your valuable guidance and suggestions. So we are really privileged to have a chair like you in this session. So now I would like to invite you, sir.
Thank you, Dr. D.K. Yadav-ji. I first invite Professor N.B. Singh, sir. So I give some Professor N.B. Singh, former head of Department of Chemistry, former Dean, Faculty of Science, DDU, Gorakhpur University, is presently Professor Emeritus in School of Basic Sciences and Research, Sarda University, Greater Noida. Dr. Singh was postdoctoral fellow at Free University of Belgium during 1973 or 74 and received the most prestigious Alexander von Humboldt Fellowship in 1977 and has worked at different universities in Germany. His main research area of research are solid state chemistry, material science, cement chemistry, thermodynamics, and water purification. Professor Singh has published more than 290 research papers and authored 8 books and written 24 books chapter in edited books published by Elsevier Springer. He has supervised 41 PhD students. He is a member of different academic bodies and he is a very renowned person. So I welcome Professor N.B. Singh and invite him to deliver his invited talk on the topic of science, society, innovation, and nanomaterials. Yes, sir.
Thank you, Professor Shukla. First of all, I would like to thank the whole organizing committee and the members of the organizing committee for giving me an opportunity to say a few words related to my present research work, as well as how the research is related to the society or how the research can be beneficial to the society, because whatever we do in any academic institution, it is for the society, for the benefit of the society. So our research is also aimed to benefit the society. My request is that maybe that I'll be taking about 40 minutes, But if you want that I should finish earlier, you just tell me 5 minutes before. I will close the lecture. I think you will allow me to share. Host, please allow me to share the screen.
Dr. Sushil, allow karo sir wo.
No, I'm not allowed to share the screen.
Dr. Sushil, sir को allow करो. तो तुम अपने को mic on करो.
Yeah, I think it is now allowed.
Okay, sir. Thank you.
Are
Yes,
you
sir.
able to see the screen?
Yes, sir. Yes, sir.
Okay. Now, as you can see, the title of my talk is Science, Society, Innovation Related to Nanomaterials. Emphasis is on nanomaterial, but how it is related to science, engineering, and the society, I will discuss in brief. It is the age of science. The 20th century's unprecedented gains in advancing human development and eradicating poverty came largely from technological breakthroughs. There is hardly any social problem on which science cannot make some contribution. Science is never sufficient to solve a problem completely, however, always necessary to use science. Now, it is the dawn of knowledge era. 21st century is the century of knowledge, and we have different type of society: agricultural society, industrial society, information society, and knowledge society. Now the question is, what is knowledge society? That uses knowledge holistically to empower and enrich people and is an integral driver of sustainable development, societal transformation. A lifelong learning society committed to innovation has the capacity to generate, diffuse, utilize, and protect knowledge, creates economic wealth and social equity, enlightens people towards an integrated view of life as a fusion of mind, body, and spirit. This is what knowledge society does. Now, science and technology, they are responsible for. They solve problems in order to improve the lives of people, solve problems in order to understand the natural world, try to find out causes of disease and try to find out a cure, seek to know what the world is made of, what forces exist, and what laws control nature. Now you see that science and society, they are interrelated. Science benefits the society and society supports the science. Science creates values, methods, and products. Society generates acceptability, equity, sustenance, and all together, that is science and society, all together is responsible for a better world. Now, science is responsible, transparent, and understand the full implications of new discoveries in the context of moral and ethical values and sustainability of our planet. Society must support about science and recognize its centrality for human good. Now, science, society, policy, and government. All these four components are needed for a better world, for a better society. So if science, society, policy, government, they merge together, eradicate poverty, secure environment, an inclusive world, then sustainable development, then a peaceful planet. That is only by doing a good science, good policy, good government, the society can make a peaceful planet. Now, when we come in the research, we always try to focus that all the time we should do innovative research, not that repetitive research. If there is no innovative research or if there is no innovation, it has no value. So in innovation, what is to be done is accept the challenge, think differently, make a change for better. If everybody is thinking alike, then somebody is not thinking. If you always do what you always did, you will always get what you always got. Great innovation only happens when people are not afraid to do things differently. There's a way to do it, better find it. Now you see that in research, we always convey this message that always try to do something new. And when you are trying to do something new, you have to take a risk. If you succeed, you will become the leader. If you fail, you become the guide. And Swami Vivekananda has said like that. That is, Swami Vivekananda has said, take risk in your life. This is true for research also. If you win, you may lead. If you lose, you may guide. Now, what is innovation? Innovation means you are doing something new, something different, something better, something cheaper, do at different location, do in different time frame. That is, there should be some novelty, there should be some newness, whatever research you do in any field, whether it is a scientific field, social science, medical, dental, or any field, there must be some novelty. Only then the research has its value and meaning. Now, why we want to do innovation? In the absence of innovative research, there will be limitation and stagnation of knowledge. There will be poverty in all spheres of life. Country will be dependent on other nations. In general, scientific research, particularly innovative research, has been identified as a prerequisite for meaningful industrial and socio-economic development. Now, materials research in nation building. In any scientific work, applied or engineering, the principle starts from science, basic science. And basic science is nothing but it is scholarship driven. It is advancement of knowledge. And it leads to applied science or technology, gainful and useful knowledge, market driven, creation of jobs. And these together is linked with the innovative research or innovation, competition driven, leadership in usable knowledge, and knowledge seekers, creation of value. They are linked for national prosperity. Now, the way forward, academia, society, industry interface. Academia, government, industry. Goal is conceptualization to commercialization. Now, academia, the duty of the academia is generate knowledge and manpower, education, research, and service. The role of industry is utilize knowledge, manpower, profit, growth, and research. Now, universities can be direct stakeholders in community development and substantially increase their participation in social development initiatives, which can be achieved through a cooperative model based on academia, community, industry partnership. Now, science, technology, innovation, society all together can make a better world, a peaceful world, and comfortable world. Now, any development in any country or in any society is directly dependent on materials. If you have good quality material, if you have advanced material, you have better technology. No material, no technology. So material has a special status for the development of any nation. Now, materials, material science, and material scientists play a very vital role in the development of a country. Development of society depends on materials. No materials, no progress. Properties of materials are size dependent. Material scientists claim that 21st century is the century of materials and especially nanomaterials. Material science and engineering innovations will continue to have a pivotal role as an enabling resource to address sustainable developmental needs, and perhaps nanomaterials may play a very important role. Now, what are nanomaterials? The word nano is taken from the Greek word nanos, meaning dwarf. It is a prefix used to describe 1 billionth of something and represents by 10 power minus 9. We can represent it, how big or small 1 nanometer is. You take 1 meter, divide by 1000, it is 10 power minus 3 meter. Again divide by 1000, it is 10 power minus 6 meter. Again divide by 1000, it is 10 power minus 9 meter. And 10 power minus 9 meter is 1 nanometer. Diameter of one hydrogen atom is 0.1 nanometer. Particles less than 100 nanometer in diameter are said to be nanomaterials, and the study of science of such materials is called nanoscience. Nanotechnology is the design, characterization, production, and applications of structures, devices, and systems by controlling shape and size and nanometer scale. Now here you see that virus, DNA, buckyball, all this butterfly, all these are in the nanometer range. Why do we want to make things smaller, that is in the range of nanomaterial? What is interesting about the nanoscale? Nano-sized particles exhibit different properties than larger particles of the same substance. As we study phenomena at this scale, we learn more about the nature of matter, develop new theories, discover new questions and answers in many areas, including healthcare, energy, and technology, figure out how to make new products and technologies that can improve people's lives. Now, what are the properties of nanomaterials, or on what factors? Properties of the nanomaterials depend. The properties depend on size of the material, surface energy, number of surface atoms, surface defects, surface functionalization, shape, surface area, aspect ratio, surface composition, and surface porosity. And all are prevalent in nanomaterials. Now, nanomaterials are being used in different sectors in the form of nanotechnology. We use it very frequently in optical engineering, defense and security, bioengineering, cosmetics, nanofabrics, information technology, food and agriculture, energy, medicine, drug, nanobiotechnology, nano devices, or in fact, I would like to mention that almost every field there is use of nanomaterial and nanotechnology. At least no field is left out. Now, how to prepare nanomaterials? There is synthesis of nanomaterials. There are two approaches. One is known as top-down approach, and the other is said to be a bottom-up approach. The top-down approach is known as physical method, and it was initiated by Richard P. Feynman in 1959 in his very famous lecture. There is plenty of room at the bottom. And Dr. Feynman got a Nobel Prize in physics. And this bottom-up approach was given by a French scientist, Jean-Marie Lane, who also got a Nobel Prize in chemistry. And this is basically a chemical route, and it is much better than the physical route. Chemical techniques, the techniques are Sol-Gel method, precipitation method, hydrothermal method, gas phase reaction, vapor deposition, electro deposition, freeze drying, spray drying, precursor, non-aqueous liquid phase reactions, laser pyrolysis, ion insertion, and then we have biological techniques, plant mediated, which we also say green route. Nowadays, much emphasis is being given on green route because of the environmental problems. Now here, the green synthesis of nanomaterials, now it has edge over the chemical method, and green nanomaterials are the nanomaterials by green route can be prepared by biopolymers, waste, heating method, microorganism, plant extract, solvothermal or solvo replacement method, that is microwave heating also comes there. The green synthesized nanomaterials have number of advantages over the conventionally synthesized nanomaterials. Non-toxic chemicals, they use non-toxic chemicals, self-reducing and capping agent, low cost, energy saving, ambient experimental conditions, eco-friendly. That's why green method is being preferred over the other conventional method. Now, how to characterize the nanomaterial synthesized? Basically, there are a number of techniques, but most important one is X-ray diffraction technique, scanning electron microscopic technique, transmission electron microscopic technique, and atomic force microscopic technique. These are the most important technique. Otherwise, there are a number of methods which I have listed in this slide. Now let us take the case of silver nanoparticle. How to make a silver nanoparticle? If we follow the chemical method, what we do, we take the solution of silver nitrate, add sodium borohydride. Sodium borohydride is a reducing agent. It immediately converts the silver ion into silver zero valent nanoparticle. But if you follow the green route, you can take any leaf extract, let us say take here neem leaf extract, add it to the silver nitrate solution and change the conditions, means change the concentration, change the pH, change the temperature, you will get silver nanoparticles of different shape and size. Not only the plant extract, you can use fungi, algae, plants, yeast, and bacteria. All these materials contain chemicals which are reducing agents. Say, for example, in fungi, algae, plant, yeast, bacteria, different type of reducing agent like alkaloids, terpenoids, phenolics, proteins, vitamins, sugars, coenzymes, naphthoquinones, anthraquinones, nitrate reductases, all these are present, and when they are added, they convert the ion into nanomaterial, neutral metal ion or nanomaterial, depending on the conditions of preparation, depending on the reducing agent, the shape and size of the nanomaterial vary. If we take the UV visible spectra, then depending on the size of the nanomaterial, you will find lambda maximum at different wavelength, and these wavelengths give an idea about the size of the nanomaterial. Now, silver nanoparticles are basically used as disinfectant. Now, in medical sector, we use for hospital-acquired infection, wound healing, medical devices, environmental water disinfectant, air disinfectant, industries. We embed the silver nanoparticle with cotton or fabrics, textiles, food packaging, animal husbandry, and number of other areas. Now, silver nanoparticles have applications in disinfection of contaminated water in order to avoid agglomeration. Nanocomposites of nanosilica is you see that when the particles become very small, they agglomerate. And when they agglomerate, again, the size increases. So the efficiency decreases. In order to minimize the agglomeration and to retain the efficiency, we convert the nanomaterial into certain nanocomposites. Basically, we use polymer or any other material can be used. So here, for disinfectant, we use silica and nanosilica. And if we mix nanosilica with silver nitrate and add this plant extract or any other reducing agent, it is converted to nanosilica silver nanocomposite. And this nanosilica silver nanocomposite kills E. coli and this aerogalsa, that is antibacterial activities are there. Use of silver ions in washing machine, a refrigerator, or an air conditioning system to sterilize, removing bacteria and odors. Silver lasts for over 3,000 wash processes and stands for 10 years. Now, what we do, we also embed silver nanoparticles to bandage. If you have a wound, and let us say you go to a doctor and doctor put a bandage and he asked, depending on the type of disease, type of wound, type of medicine, you have to change the bandage after 2 days, 3 days. But if it contains silver nanoparticle as the embedding material, then uh, then it will be lasting for more than 3 days, 7 days, 8 days, depending on what type of wound it has or what type of bacteria. Similarly, hand gloves. Doctor used to throw the hand gloves after one use, but now if it is embedded with silver nanoparticle, you can use longer. Apron, all these are now commercialized and they are available in good hospitals. Nano gold. Generally, gold nanoparticles are produced in a liquid medium by reducing a chloroauric acid. Now you see that if we adopt a chemical method, then chloroauric acid is mixed with sodium citrate. Sodium citrate is a reducing agent, and as soon as sodium citrate is mixed with chloroauric acid, silver nanoparticle is formed. Now this sodium citrate is a little bit costly and toxic, and depending on the concentration and conditions, we can prepare one-dimensional nanoparticles, two-dimensional nanoparticle, and three-dimensional gold nanoparticles. Now, here see that if we use a green route like fungus, actinomyrus, bacteria, yeast, algae, etc., you can have different shape and size of nano gold, and the size and shape varies with the type of material which you are using for reducing purposes. The gold nanoparticle with different shape produced from various microbial sources are shown here. Now here see that you know from ages that gold is golden yellow in color. It is face-centered cubic crystal. Its melting temperature is 1064 degrees centigrade. But if you convert the gold by any means, either by chemical route or by green route to nano gold, the structure changes and it becomes icosahedral. Now it's a surprise for those who doesn't know about nanomaterials that by changing the size, the golden yellow color disappears. 1 nanometer gold particles, the melting point is reduced from 1064 to 700. Lambda maximum comes at 420 nanometer and the color becomes brown yellow. If the size is 20 nanometer, the melting point is 1000 and the color is red. You see that everybody knows that the gold is golden yellow. Now if you reduce the size, it becomes red. Purple, if it is 100 nanometer, the color is purple. What is the reason? The particles are so small that electrons are not free to move about as in bulk gold, and the movement becomes restricted. As a result, the particles interact differently with light. So whatever you see in the form of a color, it is due to the interaction of electromagnetic radiation, and when the size becomes different, then there is a restriction, quantum confinement for the movement of the electron from the valence band to the conduction band, and accordingly the energy changes, and change of energy leads to change in color. Zinc oxide nanoparticle, it is also a very important nanomaterial. Chemically what we do, you just prepare zinc hydroxide, heat it at certain temperature, it is converted to zinc oxide. But by adopting green route, you can use zinc sulfate solution or zinc nitrate solution or any salt of zinc which is soluble in water. Here, what I have shown in this slide is take papaya fruit, remove the seeds of the papaya, grind it into fine powder, and then mix this with zinc sulfate or zinc chloride solution in presence of sodium hydroxide and heat it in a microwave oven. Heating in a microwave oven means it takes less time. Immediately you will get zinc oxide nanoparticle. Here you see at the bottom you have high resolution transmission electron microscopic picture of zinc oxide nanoparticle, and this is the X-ray diffraction pattern of zinc oxide nanoparticle. Now this X-ray diffraction pattern, as I pointed out earlier, is a very powerful tool for determining the size And if we determine the size by X-ray diffraction technique, we say crystallite size. Instead of saying particle size, we say crystallite size. And there is a formula known as Scherer formula, which is used to determine the crystallite size by X-ray diffraction technique. Now, zinc oxide, apart from other properties, has wonderful optical properties. Here you see that. You might have seen earlier that the cricketers used to have their faces white in the sun so that there is no etching from the ultraviolet radiation coming from the sun. That is nothing but zinc oxide microsize. Today also they use, but you don't see white faces. They are using same zinc oxide, but of nano size. Now here, large zinc oxide particles block UV light, scatter visible light, appear white. Traditional zinc oxide sun screen is white. Then nano-sized zinc oxide particles block UV light, so small compared to the wavelength of visible light that they don't scatter it, appear clear. So nanoscale zinc oxide sun screen is clear. Now, not only zinc oxide, but there are a number of other nanomaterials which are given to fish, and they increase the weight and size of the enlarged period. Zinc oxide has also antimicrobial activity, is similar to nano zinc. Now, a lot of nanomaterials are being used in cosmetic industry. Now you see that there was a time, if you have a face powder or cream, you use a lot of things. Now, they contain nanomaterials, so only a small portion of that is sufficient as a face powder or as a cream or as a lipstick or whatever cosmetic you use. And number of nanomaterials like silver nanoparticle, fullerene, gold, silica, zinc oxide, mica, titanium, copper, platinum, aluminum, etc. are being used in cosmetic industry very successfully, but they are costly as compared to the conventional cosmetic material. Another very important material is carbon nanotube. You see that we have basically two types of carbon nanotube. One is single wall carbon nanotube and the other is multi-wall carbon nanotubes. There are a lot of applications of carbon nanotubes. Carbon nanotubes are being used to develop flat screen televisions with higher resolution than the human eye can detect. Your next TV screen could be thin, ultra light, and foldable. At the moment, you can't fold a TV screen or this laptop or any screen, but it has already been done. It is to be commercialized soon that with the help of carbon nanotube, a foldable screen can be made. Use of carbon nanotube in solar cells could vastly improve their efficiency. Branching and switching of signals at electronic junctions is similar to what happens in nerves. A carbon nanotube's neural tree can be trained to perform complex switching and computing functions. CNT could be used to detect, respond to electronic, acoustic, chemical, or thermal signals. Badminton rackets and tennis rackets incorporate carbon nanotube. Bicycle incorporate carbon nanotube. The reason being, carbon nanotube is very light but very strong. So if the racket contains, it becomes very strong but at the same time very light. Same is true with the bicycle. Carbon nanotubes are being used, are number of, not only carbon nanotube, many other nanomaterials are being used in construction industry. What is the role of nanomaterials in construction industry? It increases the strength, rheology, accelerate the cement hydration, refine the pore size, antibacterial, durability, photocatalytic, and other durability phenomena are there. You see that if you construct a building and after some time, maybe 6 months, 8 months, 1 year, you find there is a crack formation. And if you have already added carbon nanotube, then this carbon nanotube will work as a bridge and it will save the building from collapsing. And it will give some time so that you can correct it, you can modify it, whatever you want, you can do it. If you use simply 0.01% carbon nanotube in the semen, the strength is increased considerably, and this nanomaterial, particularly titanium dioxide, nano zinc oxide, they are used as self-cleaning material. And what happened? Let us say titanium dioxide is a semiconductor material. If a visible light or ultraviolet light falls on it, the electron from the valence band jumps to the conduction band. A hole is created in the valence band, and a free electron is available in the conduction band. So it destroys the organic matter, which is a dirt, and it cleans the surface. Not only here, it is very much used as a photocatalyst in water purification and at various other places. You might be knowing that there are some very big buildings, for example, Burj Khalifa, which is the tallest building in the world, 108 meters high. And if you want to clean this surface after 2-3 years, it will be very costly. So it contains paint containing titanium dioxide. You might have heard the name of the car Mercedes. Mercedes car even today is considered to be a very good car. Its color lasts for many years because it contains this type of material which is self-cleaning. Here you see that there is a church in Italy, and it was built perhaps in 2002, and since then it has never been washed, and its whiteness is same as it was while it was being built. Nanotechnology based textiles, you can have antimicrobial textile. If you imbue with certain type of nanomaterial, you can make antimicrobial textile, flame retardant textile, super hydrophobic textile, nanofibrous scaffold in tissue engineering, nanofibrous in wound healing, nanofibrous in automotive fuel cell, nanofibers in filtration, wearable textile battery, stimulate responsible textile, nanosensors in textile, light emitting garment, wrinkle free fabric. All these type of textile, they are already available in the market. Only thing is that it is costly, it is beyond the reach of common people. Number of nanomaterials in the form of nanocomposites are being used in automobile industry. Here you see the picture where in different parts of the car you have use of nanocomposite or nanomaterial. Nanomaterials are being used in agriculture now extensively in the form of this fertilizers, in the form of this pathogenic killers, pesticide killers, and all these things are there. And when they enter into the cell of the plant, some of the nanomaterial like zinc oxide, silver, or copper, the growth of the plant, growth of the seed, growth of the flower is increased considerably. So they are very much being used today in agriculture. Researchers are experimenting with new pathogen disabling nanoparticles to keep chickens healthy. You see that, particularly in chickens, if there is some disease, whole chicken dies out. Now they are doing that. Nanoparticles are added to feed and mimic cell surfaces inside the chicken. The tiny pathogens get confused and bind to the particles instead of real cells, then flush out. They go through the digestive system, keeping chickens safer and healthier. Now it is predicted that if it is beneficial to chicken, then next. If it works on chicken, then who is the next? Now, at last I would like to show this slide. Chameleons, girgit. We always say कि ये आदमी गिरगिट की तरह रंग बदलता है. That is the girgit. If it does twist, there is a change in color. Why? Chameleons have two superimposed layers within the skin that control their color and thermoregulation. The top layer contains a lattice of guanine nanocrystals, and by exciting this lattice, The spacing between the nanocrystal can be manipulated, which in turn affects which wavelength of light are reflected and which are absorbed. Exciting the lattice increases the distance between the nanocrystals, and the skin reflects longer wavelength of light, yellow, orange, green, and red. And in a relaxed state, the crystal reflects blue and green light. So it is the beauty of this nanomaterial. You see, it is the structure of the guanine, which you see, it is nothing but organic compound, and the nano layers of these organic compounds are there. So just by changing the size and the space between the two layers changes, and you get different colors. So this is all. Thank you very much.
Thank you, sir. Your talk is very valuable and informative about the nanomaterials, and it is used in many places. You can explain very beautifully. Now session is open for question. If any participants wants any question, they can ask and write in chat box. Any participants? If you have any question or doubts.
Professor Shukla,
Yes, sir.
if there are no questions, there are only two answers of that.
Yes.
Either the speaker has not conveyed anything which he or she wanted to convey, or the audience did not understand anything.
Nice, sir. You can explain very beautifully and very easy way. So I think all participants are understand it. And your talk is very good, sir. I thanks you again, sir.
Thank you, Professor. So can I leave the meeting now?
Yes, sir. Yes, sir. Thank you, sir.
Thank you. Thank you all the members of the organizing committee, and particularly Professor Shukla, Professor Singh, Professor Nishant, Professor Yadav, and the member of the college management. Thank you very much.
Thank you, sir.
Thank you, sir.
Now the second session is, in this session, there are 4 invited talks. And the invited talk delivered by Dr. K.P. Misra, Dr. Ashok Kumar Misra, Professor Ranjana Jha, and Dr. S.K. Yadav. The first talk by given Dr. Kamakhya Prakash Misra on the topic of role of co-dopants in aluminum doped ZNO nanostructures. And the brief introduction of Dr. Kamakhya Prakash Misra is that he has obtained his PhD from the University of Lucknow and currently serving as an assistant professor at the Department of Physics, Manipal University, Jaipur. He has published more than 40 research articles in various international journals. He has been the guest editor of a special issue published in Journal of Nano and Electronics Physics and Materials Today Proceeding. He is also involved in editing a book series on ceramic science and engineering to be published by Elsevier. He has been reviewer of several high-impact journals like Thin Solid Films, Applied Surface Science, Journal of Alloys and Compounds. His current research interest includes application of various spectroscopic tools for the evaluation of material behavior, temperature-dependent luminescence in rare earth-doped ZNO, and polymer-embedded piezoelectric nanogenerator for energy harvesting, etc. Now I invite Dr. Kamakhya Prakash Misra to give invite.
Thank you, sir. Thank you very much for such a nice introduction. Good afternoon to one and all. Just give me a second so that I can share the screen. Is my screen visible? Please, somebody respond.
Yes,
sir?
yes.
Okay.
But you can use a full screen.
Yes, I'll do that. So good afternoon to everyone, and my special thanks to the organizing team of NCAIR 2021, and they have given this good opportunity to me to express my views on the topic of role of co-dopants in aluminum doped zinc oxide nanostructures. So in the previous talk, we were having the discussion on nanomaterials. A lot of nanomaterials were described and discussed by Professor N.B. Singh. Here I'm taking another dimension of the materials research. Apart from the size, some impurities or some kind of modifications in the materials, they also play a crucial role in determining the specific properties of different materials. So that specific property I have chosen here of zinc oxide, and that property is modified by the use of co-dopants. So that is the overall view of my topic. Now, this is the slide which contains the beautiful view of my university where I actually work. So different angle views are shown in the slide. So whenever you get a chance to visit the city of Jaipur, Pink City, so I'll be happy to host you and I'll be happy to receive you at my university, and I would like to show you the facilities, research facilities available at my university. So all the participants are welcome to visit my university. So this is the brief content of my talk. I'll be talking of doping, then doping and co-doping. I've encircled the term co-doping. I'm going to pay more attention on the term co-doping in semiconductors. Then zinc oxide as a whole, the significance of this material, and what is the role of aluminum doping in the zinc oxide material. And then several co-dopants which I have used in my laboratory. I would like to share the results that we have obtained inside my laboratory, and then at the end, the summary of my work. So doping, I can see the wide spectrum of the participants from various backgrounds. So this doping term may be confused with some other term. It is also very popularly used in the field of sport where it is prohibited. So that doping I'm not going to talk about. That doping is banned, and that is actually indicating the meaning of consuming some banned drug to enhance the performance. So I'm not talking of that doping. I'm going to take the doping that is used in a very positive sense, in a very positive manner. In fact, in today's world, a big technology is being run based upon the doping inside the material. Semiconductor is one part of the material. There are other materials, they too are doped with some material from the outside. So let us understand the actual meaning of doping. So doping is actually the intentional introduction of impurities into an intrinsic semiconductor. So many of the participants who are having the background of science, they must be knowing about this term of doping and semiconductor. So semiconductor, its properties can be highly modified if we incorporate some kind of impurity into that semiconductor material. So by incorporating the impurity into the semiconducting material, we can actually modulate various properties of that semiconductor material. Initially, it was intended to enhance the electrical conductivity. The purpose of doping into the semiconductor was to enhance the electrical conductivity, but with time it was found that it is not only the electrical conductivity, there are many other properties, they too can be highly tremendously affected by doping. So optical properties, electrical properties, structural properties, or even magnetic properties, they all can be modified in a very systematic manner by using a suitable dopant. And the ideal requirement for the dopant being used for any host semiconductor material is that it should be having ideal solubility. It must be soluble to that material. It must be consumed within the material. It should not show its own existence in a separate manner. That is the ideal requirement for a suitable dopant inside any semiconductor material. What happens when we dope the material, then material properties can be changed, and there are materials which are showing excellent material properties by the use of several dopants. For example, if we take silicon, so silicon can be doped by some pentavalent element. It can also be doped by some trivalent element. As a result, we get two types of semiconductors, p-type and n-type. But there are certain materials, certain semiconductors, where it is difficult to find both types of polarity or both types of doping behavior. Like, we cannot, certain materials are there where we can produce the n-type material, but its counter p-type material is not possible to be produced. And it's vice versa is also true. And that problem is specifically existing with wide bandgap materials, wide bandgap semiconductors. There are materials, semiconductors, which are having band gap little larger than the conventional semiconductors. So this problem, how to address that? So to address this problem of bipolar doping, unavailability of bipolar doping in semiconductors, that could be addressed by co-doping. It's a very promising strategy in today's materials world. Nano size, reducing size, going to the nano dimension is one aspect of materials research. This is another aspect which I have taken in today's talk. So co-dopant here, the if you see co-dopant, I'm not taking this C capital, because if you take C capital, it may confuse you. It can give you a notion that it is cobalt. So it is not cobalt. Co-doping means along with dopant, another element has been doped along with one dopant. So that is called as co-doping, and it has been proved to be a very promising strategy for channelizing, for modulating the various properties of different materials. So it was found to be efficient for increasing the dopant solubility. There were cases where dopant was not getting consumed within the material. So co-dopant was found to be creating such a situations inside the material that the dopant was having more solubility. It was also found to be increasing the activation rate of ionization within the material. And co-dopant also contributed in terms of carrier mobility and carrier concentration. For example, if we take the example of gallium nitride, so when we dope it with magnesium, then its carrier concentration, whole carrier concentration was 10 to the power 17 centimeter per centimeter cube. And if it is co-doped with oxygen, then the carrier concentration was found to be increasing by an order of magnitude. It was becoming almost close to 10 to the power 20, 23 or 24. So this much rise was seen by the use of co-doping. So that is the power of co-doping. So co-doping can be classified in three categories. One is called as fully compensated co-doping, another one is partially compensated co-doping, and the third one is non-compensated co-doping. So fully compensated co-doping, here in simple terms, if we like to understand, whenever we dope, what happens, the Fermi level which lies at the middle of the band gap in an intrinsic semiconductor, that gets shifted on one side by the use of doping. So if we are using two dopants, what will happen? One dopant will try to shift the Fermi level upward, and if other one is trying to shift the Fermi level downward in such a way that Fermi level remains at the middle. Even with the use of dopant, Fermi level is lying close to the middle of the band gap. That means we are compensating the effect of one dopant by the use of co-dopant. So such doping is called as fully compensated co-doping. So it was not found to be very promising strategy. We have tried it with different materials, but it was not found to be very effective in terms of directly enhancing the carrier concentration. The other side, partially compensated co-doping. That means the effect of one dopant is only partially compensated by the other dopant or so-called co-dopant. So this strategy was found to be very promising. It was found to create the intermediate levels within the band gap of the host system, and it drastically enhanced the solubility of the dopant, and also it changed the band gap of the material, and it was also found to enhance the optical absorption and other optical properties. So this partially compensated co-doping was found to be a very promising technique, and it is nowadays very much applied in the field of modification of different materials. Then third one is non-compensated co-doping. It is also having some novelty. So here we use some isovalent material as a dopant, like we choose the dopants which are lying in the same group of the periodic table. So they are found to enhance or affect the magnetic behavior of different materials. Though they do not enhance the carrier concentration, but they were found to affect the magnetic domains of the material. So they are finding more popularity in terms of magnetic properties of the material. So what should be the host? So host, of course, we use the wide band gap material. So here are certain wide band gap materials listed in this slide. So I'm going to talk more about zinc oxide, where actually I work. So zinc oxide is a very popular material, and in fact now it is becoming a little infamous because of so much work being done on zinc oxide. So it is a wide band gap semiconductor. It is having good biocompatibility, good level of transparency, high electron mobility, room temperature luminescence. All these properties make zinc oxide very much explored material in today's world of material science. And specifically, if we talk of dopant, so aluminum doping has got a certain level of maturity in zinc oxide. It is having a very good balance of enhancing the electrical conductivity along with maintaining the transparency of the material. So this aluminum doped zinc oxide, briefly called as AZO, is nowadays finding commercial application as transparent conducting oxide in thin film transistors and many other devices. So what I have done, I have chosen this mature material, aluminum doped zinc oxide, because aluminum doping in zinc oxide has got a certain level of maturity. So I have started using the co-dopant in AZO or in aluminum doped zinc oxide. For preparing the material, I utilize a very simple method in my laboratory, that is sol gel method. So sol gel method is having a very brief step. We begin with the certain precursor materials, and those materials, they are converted into some kind of gel, and those gel can be either converted into a thin film structure, and also they can be converted into the dense powder or ceramic material. So this is the brief overview of sol gel methods. So here I'm showing you the results of silver doped or silver co-doped aluminum doped zinc oxide material.